Good afternoon, everybody, and welcome to the latest in our series of webinars. This is guidance for humidifier users. Firstly, thank you for registering and thank you for joining. My name is Dave Marshall-George, and I'm the UK and Ireland Sales Director for Condair. I'm going to be hosting today, but presenting is going to be Darren Bryant. Darren is the Area Sales Manager covering London and the South East for Condair, and Darren has over 30 years experience in humidification. The webinar should last 45 minutes and there'll be a 15-minute section at the end for questions and answers. There is a GoToWebinar control panel on the right side of your screen where you'll find the audio options and the questions tool. All attendees are muted throughout the session, so please use the questions section of the GoToWebinar control panel to type in your questions. And I'll be trying to answer some as we go through, and then we'll ask Darren some of those questions at the end. There are some handouts as well that you can see from the control panel. There's the Condair product range, there's humidifier service and maintenance brochure, there's the humidifier disinfection leaflet, and a presentation, the slides from the presentation as well. Following the session, after an hour, all attendees will receive an email with a certificate of attendance and a link to a recording of the webinar. So without further ado, I'm going to turn my camera off and hand over to Darren.
Thank you, David. Thanks very much for that. I hope you're all well today, and hopefully this is going to be of some enjoyment, and you can hopefully take something out of it today that you may have not learned before. But please feel free to fire those questions at the end if you've got any further information you need or any queries. Okay, right. So my name's Darren Bright, as David's mentioned. I'm the Area Sales Manager for the London and the South East, but my career has been mainly based around servicing of the equipment. So I've got a reasonably good knowledge of our equipment and also some of the others that I've dealt with over the years. So hopefully I can impart some of the information on you today to take away and be of use. So what we're going to do today is just basically start from the very beginning, give you some basics of why we need a humidifier in an application. Then we're going to look at also some different types of humidifier, mainly in the groups as in steam humidification, isothermal, and then we'll look at adiabatic humidification in the form of an evaporative or a spray system. Then we're going to look at some of the requirements, obviously, for hygiene management, obviously as part of your water management scheme for buildings to look after these cold water systems. Then we're also going to look at how we improve on an existing system by maybe upgrading to a bigger or more expensive close control system to help you out with controllability and operation. And then we're just going to touch on some basics on common errors that we see day in, day out, obviously with installing humidifiers and problems with servicing of equipment. So just to start off, we tend to look at humidification in sort of three block areas. First area is productivity. Now, this is going to be in the form of like pharmaceuticals or process areas where they're looking to keep the equilibrium of the product in check so they're not losing any weight. Also to control static in certain areas to make sure they're not losing out on production time. We're also going to look at how we improve our health and what we're looking at now, especially prevalent at the moment with the COVID issue in terms of offices. We're also going to look at preservation as well, to look at mainly going to be galleries, museums, which are looking to preserve materials which are mainly going to be hygroscopic, which are going to be affected by big changes in humidity. So just to drill down a little bit further, improving productivity, as you can see here, these are some of the areas that we deal with day in, day out with humidification. Commonly, we see a lot of work off with MRI scanners for mainly to preserve the life of the warranties for their MRI scanners, because if they break down and they're outside the scope of humidity control, that effectively invalidates the warranty with MRI scanners. We also get involved with data centers, mainly with adiabatic cooling, print and electronics. So the areas that we deal with are vast. I can't go through everyone because we haven't got enough time for that, but that just gives you an overview of what we deal with on a day-to-day basis. Moving on to health. Obviously, this is extremely prevalent at the moment in terms of the marketplace. And we're seeing obviously Sage offering guidance now to talk about air change rates, but humidification is also something that needs to be looked at and closely monitored. Basically, if we're working in a dry atmosphere of less than 40%, we've got a protective mucous membrane in the back of our throat, which acts as like a barrier to prevent these nasty airborne pathogens with the coronavirus floating around in the airstream, entering into our lungs. Now, if that mucous membrane dries out because of the drier atmosphere, it makes it less effective to work. So we need to obviously raise our humidity to 40 to 60 to protect this mucous membrane when we're actually working in an office environment. Also, what you're going to find is when you've got a drier atmosphere, those airborne pathogens will float around for longer periods because it's got no water molecules to catch onto or attach itself. So you're going to find the float time of a virus will actually still be slightly longer in a drier atmosphere than it would be in a moist atmosphere. So what we're trying to do is trying to create water aerosols to pull that pathogen out of the air and down to the floor. If you've got a moist atmosphere also as well, what it's also going to do is going to deactivate the virus as well. It actually reduce the susceptibility of the virus to carry on surviving in an environment. So water molecules is a very, very good thing to make sure that you've got the correct humidity to reduce the risks of airborne viruses. We're also going to look at preservation. Now, preservation, I'm sure some of you guys, and I think I know some of the guys may be visiting today, actually, I met them last week. They're dealing with expensive artifacts which will have hygroscopic materials, which will change their size and shape with humidity. Now, if they're carrying out an exhibition, they have to prove their insurances are actually robust and confirm probably 3 months worth of actual records to understand that their humidity levels are stable. Because if they don't do that, then there's a fear of damaging this artwork. So preservation is exceptionally important with humidification control. So wooden floors, church organs as well, that's another one that we get involved with heavily as well. But those are just a snapshot of the preservation areas we get involved with. So we're now going to move on to the products. Now, what you can see there is steam. Well, I'm not exactly telling the truth there. Well, it's not actually steam. You're seeing water vapor being displaced by the steam which has been introduced into the air. So steam is actually invisible. So when you see your kettle boiling at home, it's not actually steam coming out. You can physically see steam. It's the water vapor being displaced by the steam. So very carefully how you assess that, but steam is actually invisible. So I just thought I'd show that as a slide just to give you an understanding of what you're physically seeing. So what I'm going to do today is look at, first of all, the electric isothermal steam humidifiers. And I'm sure if some of you guys are FM companies, obviously you've come across the good old electro boiler. Now, the good old electro boiler first came out in the marketplace in the 1960s by Eaton Williams, and they put that in the marketplace. And it's the first electro steam isothermal boiler on the market. And the basic principles of it is that you're going to have a polypropylene cylinder, which will have a number of electrodes fixed inside the cylinder itself. Now, that can either be fed by a single-phase supply or a three-phase supply. And those electrodes can either be in the form of a mild steel mesh plate, or it could also be a stainless steel plate, depending on which manufacturer you're using. So these systems will just purely work on the basis of actually introducing raw mains water, and I mean raw mains water, to actually allow the electricity to conduct between each electrode to boil the water and produce steam atmospherically. Very similar to your pressure at home with your kettle. So very, very simple system. They're very, very quick and easy to install on the wall with a cabinet, water in, drain out, and then your controls normally going to be in the form of like a 0 to 10 volt control signal to drive it up and down. And then they have the enable or disable circuit to switch it on and off with a fan, or if there's a high limit in the supply duct, to switch it on and off. But what you're going to find with an electro boiler, it won't give you the really quick, fast response close control you need in certain applications like processes. But it's more than enough for obviously for commercial buildings where they're looking at a research system, 10% fresh air, and they're perfectly okay. However, now if you're working on particularly hard water, you're going to find that they are going to scale up. Now, for example, London Water, you could be looking at maybe 3 or 4 maintenances a year to try and keep these units in check, certainly if it's 24/7 operation. So it's very vital that you have a suitable regime in place. Now, the thing is also with these, because we're boiling water, there's going to be a high energy consumption. So you're looking at, if you're looking at 100 kilogram an hour system, you're looking at 75 kilowatts of electrical energy to boil 100 litres of water an hour. So that's quite a high energy consumption. So If your maintenance commitment is high, you could be looking, as I say, 2 or 3 maintenances a year. And what you should be looking for with the maintenance is you should be taking these cylinders out, inspecting the plates or the electrodes to make sure they're intact, or if they're heavily scaled, then you should actually replace them. Now, in most cases, these humidifiers will actually have a way of measuring the current draw. And then they will look to detect a current draw over a certain period of time. Now, if that goes out of that certain period and it can't achieve the correct current draw, it will flag up an alarm. And with most of these units will actually have common alarm fitted to them to send a signal back to your BMS. But obviously cylinders, you need to make sure that you have those available and replace them when they're heavily scaled. Also, the most important thing when you're changing a cylinder is to make sure that drain pump that dilutes the water in that unit is also checked as well. Because I've seen so many times where people have taken the cylinders out and they forgot to clean the pump. They put a brand new cylinder back in and they find that the cylinder gets wasted or damaged very, very quickly straight after fitting. So it's very important to change that pump or check the pump and clean it. Also, water pressure is vital to check as well, because obviously the valves that allow the water into the unit are set to a certain flow rate. And it's normally about 4 times the boil-off rate of what the valves will be set for. And this is to keep the water on current levels higher to allow you to get the capacity out of the unit. Now, if that flow drops off or is reduced in some way, you're going to find the water levels are going to creep lower and lower in the cylinder. And you're going to find then it's going to affect the electrodes and possibly damage them. Now, I'm sure some of you may have even seen a situation where it's actually electrically arced across from one plate to the other. That's more damaging, obviously, to the electrodes themselves, because obviously the zinc coating that stops them from rusting comes away and the mild steel gets exposed and they can literally just erode away. So it's very important that that drain pump is checked and it's set correctly in terms of dilution drains. Water quality, as I say, we're all looking at hard water, but obviously you may find in places like Scotland the water is exceptionally soft. So you might have to fit a different type of cylinder, or it may be a case it might be too low and you can't get it to work at all. You can put salts in and Alka-Seltzer in, but it will only work for a short period of time. So that's another one to consider. Electrical connections, always worth actually trying to talk up the connections, the big power connections on the contactors, on the solid state relays, and also making sure the caps are tight as well, because they become loose and they're going to create a high resistive joint. So that's always worth checking. And obviously the numbers of changes or number of service intervals will be determined by how hard your water is. Now, if you don't know what your water hardness is, it's always worth having a look at the water authority that you're being fed by your postal code, and they will give you some readouts of what your hardness levels are. And conductivity is what we tend to work on. So if it's over 500 microsiemens of conductivity, that is what I would class as hard water or very hard water if it goes even higher. Okay, that's the electrode boiler. Now we're going to look at the resistive heater humidifier, which is another electric humidifier. Now, this is very, very simply a bit like your kettle at home. It's going to have a heater element inside a stainless steel boiling vessel. Now, albeit it's going to be a lot more sophisticated in terms of how it operates, because it's going to have a number of elements in there. And the main benefit of these units is you can burst fire the elements to give you really tight control, fast control, which you wouldn't get with the electrode boiler, because you're just relying on current draw, which is going up and down very slowly. So with these resistive units, you can get close control plus or minus 1 to 5%, depending on the design of the system and the temperature range as well. With these, also, you can run them on different types of water. So you can run them on your raw mains if you want to. You can run them on softened. Also, you can also run them on RO water as well. So they're very compatible with different types of water. Ideally, we would normally recommend RO water, because you're taking 90% of the solids out, and that allows you then to reduce the number of maintenances you're having involved with the equipment. And also, if you're draining less with the system, you don't have to drain so much, you're reducing the amount of wasted energy to drain as well. So that's an added benefit of RO, albeit your water consumption may go up. So that's another thing you've got to consider. The steam outputs are going to be very similar to the electrode boiler, anything from 5 kilos up to 90 kilograms an hour. You're still going to be boiling the same amount of energy, obviously, to give you steam, but this is going to be a way of giving you some good close control with lower maintenance. Now, also the consumables with these are going to be less. You can imagine with the electrode boiler, you could be spending £300 or £400 a time to replace those. Now, the consumables on these are normally going to be like gaskets, seals, or this particular one you can see in the picture, scale collector, every so often. So there is less to consume in terms of spare parts, but got to consider with these are a bit more expensive than your electro boiler, probably about 3 times the cost, but it's horses for courses with this. If you've got close control and you want to have less downtime, a resistive humidifier is the way to go. In terms of maintenance, you're going to find that you're going to have to clean the cylinders out. There'll be an internal liner in most cases with these units, which you need to clean out and replace every so often. And the liner is there to prevent you getting scale on the insides of the tanks. The gaskets, the neoprene gaskets that seal the top half of the cylinder and the bottom half would need to be replaced every year, we recommend, because they become depressed and they don't reseal correctly. So it's always worth just changing the gaskets on those cylinders. And the most important part of a resistive humidifier is the water level detection. And that could be in a variable capacitance, if it's an affect sensor, which is some of those units that are out there, or it could be a float, a reed switch. It's always worth just checking those switches as part of your maintenance, because if they get stuck, it's going to create issues with the operation of the unit in terms of output, but also with the float operation, it's going to create inconsistent water levels in the tank. The scale collector, as you can see on this one, it will be plastic, so there will be a plastics change every so often with these units. Again, very important to look at drain pumps and look at the inlet valve to make sure that is actually operating correctly. Always worth just taking the strainer out in front of the valve to make sure that's clean, so you're getting the correct flow rates through. Because if you don't, then you get inconsistent levels on your floats, and you won't get the correct operation out of the unit. So that's now the 2 electric steam humidifiers you see in the marketplace. There's also another one which we see out there, which is gas. Now, gas tends to be working on higher capacities. You're probably looking around sort of 4 or 5 meters cubed plus of fresh air. This is what we're going to be humidifying, fresh air. So these can start from anything from around 20 odd kilos up to 260, 300, 400 kilos in certain cases. So they're big units. Now, these tend to be supplied in either what we call a gauze face burner, as you can see here, which gives you very, very high efficiency to transfer the heat from these heat exchangers into your water to get it to boil. Or you can also see a 360-degree radial burner, which will give you a controllability as well. Now, with these systems, very similar to the resistive, you can use them with different types of water. You can use it with your RO water, your softened water if you want to. But what you've got to consider with a gas is you've got to look at obviously the gas supply to start with, the fluid to run the CO2 or the combustion gases away, and also you've got to have ventilation in your plant room. So not every plant room can take them, but what you're going to find is that there's more requirements involved. Cost-wise, they are going to be a bit more expensive than resistive, but obviously at the moment, as we say, gas is a little bit cheaper to run than electricity. That might change obviously with renewable energy in the near future, but at the moment, gas is an option if you're looking at big duties. It's going to be a lower run cost. The pros and cons obviously with these is you're having to keep these heat exchangers cleaned up and remove the scale continually to make sure these heat exchangers are reaching the correct temperatures to boil the water. The other thing to consider with a gas unit is the fact you can't use a standard maintenance engineer. It's got to be gas safe, and they're going to be gas safe to a commercial ticket to actually service these units. So invariably, what you're going to be doing with these gas units, you're going to be cleaning up these heat exchangers depending on how hard your water is. Now, what we tend to do, we tend to offer a main service, which is going to be taking the igniters out, removing the burners, and then we'll have a minor service, which will just purely going to be checking on the operation, but cleaning out the heat exchanger. So what you're going to find is you're also going to have igniters and flame sensors that fire up the burner to get it to spark, or to get it to put an electrode on to fire up the ignition system. They will wear out after a period of time, and especially if you're on a system where you're looking at close control, where you're firing the burners on and off. So generally, we recommend sort of 2,000 hours to a yearly look at those igniters and maybe replace them. Also, water level detection, as I said again, is a very, very important thing to consider. With the gas unit, as part of the main service, it's always recommended to check the safety devices, as in pressure switches on the airflows of the burn blowers. Also checking the flue temperatures, making sure they're correct, And what we'd also recommend when you do a main service, when you're taking the burners out, is to do a complete check of the gas valve mixture to make sure you're getting the correct settings of that burner, so it's working as efficiently as possible. Okay. I'm just going to have a quick drink because I can feel my voice going straight away already because I'm talking too much. Right, now we're going to move on to adiabatic and cold water humidifiers. Come with a slightly different set of rules in terms of servicing, but all the way could be some benefits to certain users. So I'm just going to show you a brief video of an evaporative system. Now, normally in an evaporative system, you're going to see a system with glass fibered sheets fixed in a cassette, a stainless steel cassette. Then your air passing through the media, which will have water trickling down through the media, will evaporate that water off the media and then give you some humidification and cooling. And then what you can see here is that if for every 1 litre of water you're actually dissipating out of that unit, you can achieve 680 watts of cooling. And this is the reason why we're seeing a lot of these now looked at for computer room air conditioning systems, and also for data halls now to give you some low energy cooling. Just to expand on that, I'm just going to show you the system now in situ. This is our system, this is the ME system that we use, but obviously you've got other systems out there, Munters and Fizz-Air, very similar systems, but we use multiple stage pumps. Now in most cases what you're going to find is you're going to have glass fibered sheets in here, all bonded together, a number of sheets all bonded together to give you what we call a saturation efficiency. So the thicker the media the unit is going to have, the more water it can displace into the air. So these units can be anything from 600 millimeters wide up to 7.8 millimeters wide. We've done big systems. And the duty, you can go from anything from sort of 30 litres up to hundreds and hundreds of litres. So the very, very high capacity. And this is all being delivered by a pump set that's probably going to be about 0.5 kilowatt. So it's very, very low energy. The maintenance requirements for these obviously tend to be looking at the tank itself. Now the tank will normally have to be disinfected twice a year. And also you have an hygiene option to help with the hygiene of the tank, and they will need to be checked as well. But there's very little maintenance in terms of what you replace. The only real maintenance is going to be the consumables like the bulbs that you replace or the filters. And then eventually you'll have a cassette replacement. Just to give you a rough guide, depending on hardness of water, in London, if you're working 24/7, it's not uncommon to have a cassette replacement, say 3 to 5 years. So depending on the size, that can it's quite a chunky cost, but obviously it's something you need to program in to your budgets if you are looking to have these in place over a 3 or 5 year period. In terms of the installation of these units, obviously they're going to be putting into an application for humidification. It's very, very important to have the correct preheat onto these units, because the adiabatic process is cooling the air at the same time. If your preheat isn't sufficiently high enough in the winter, normally going to be 30 degrees above, you're going to find that you're going to struggle to get the conditions in the room itself. So preheat is a requirement for these. So you've got to have indirect gas heating to make the benefits of the energy savings there to give you the control you want. So generally from an evaporative media point of view, it's mainly going to be to do with the tanks. What you're also going to find is you need to inspect the media. Because it's a glass fibered sheet, it's not particularly robust. So you can't go in there with screwdrivers and poking scale out. You've got to be cleaning it with a very, very light brush on the face of the media. And then what you would do is also you would clean the tanks out and make sure you clean the tanks to the point that there's hardly any debris in the tanks, because anything left inside the tanks, that's going to act as a nutrient for bacteria to grow. So what we tend to do, we can make the tanks extremely clean, and we sometimes use Fernox to get rid of all the scale build-up in the tanks. And then we'll also periodically change the UV lamps on these systems. Now, the UV lamps can be either a direct UV for the water incoming supply, or you can also now have submersible UVs and recirculating UVs. But generally, to make them as effective as possible, we recommend that UVs are replaced annually, because the UV rays will deteriorate over a period of time. and also the quartz sleeves, if they haven't got a sediment filter in front of them, will actually cloud up and not give you the full extent of the UV rays on the water, which can kill off the bacteria. You can also have silver filters, which will dose silver into the system, and silver will just act as an inhibitor. It won't kill at the same rate as what a UV system will do, but it will actually keep that tank in check. What the most important thing to consider with these systems is water movement, making sure the water is being moved through the system, purging the lime before the system, and making sure the unit dilutes on a regular basis. Also, what we recommend is you take the cassettes out, because obviously you can see the face area at the front might be scaled, but if you're taking them out, you're going to have an appreciation for how heavy they're getting to give you an understanding when you will replace those cassettes. Very important. Also, from periodically, sometimes depending on usage, it would be useful to change the hoses, because sometimes you do get a little bit of bacteria stuck in those hoses. So we recommend maybe a year or every couple of years, depending on usage, to change those hoses out, which connects the pumps to the cassettes themselves. One of the most important things to consider is flow. The cassettes are designed to give you a certain capacity, but also what we call washover. So we wash the cassettes over to make sure we're pushing the scale through the system and into the tank. So it's very important to change flow restrictors to make sure they're giving you the correct flow. And if you're using pumps, it's also to correctly set those pumps on a regular basis. Because if you don't get the correct flows over the cassette, then you're going to get inconsistent evaporation, and also you're going to get more scaling. So it's very important to make sure you get the restrictions and the settings right. When you're going to be disinfecting, you're going to be putting in chlorine, which is a requirement by HSE. We're putting 50 parts per million of chlorine into the tank and trying to circulate that around the system. Depending on the size, it might be 1 or 2 hours. And then what we're going to do then is dilute that chlorine and then use a neutralizer to get rid of the chlorine in the system. And to add to that, obviously, when you've been moving things around and changing things, you're going to find you're going to be moving stuff. So it could maybe scale in the system by changing hoses. We always put a disinfection tablet in the tank after we leave, which is a slow release disinfectant to help with keeping the tank in check. So that's the adaptive humidifier. Some of you may have actually seen these types of systems many moons ago. We actually started off actually putting spray systems into print areas because of paper curl and issues with static. And this is the ideal way of doing this by using a mixture of compressed air and water, which is joined into either side of a stainless steel or nickel coated, brass nickel coated spray nozzle. So these nozzles are normally mounted at one end of the room, or it could be mounted in a different L shape or H shape pattern above the working area. And these are normally going to be mounted in industrial areas where you're looking to spray. You're not concerned too much about noise, because obviously with the compressed air and water system, you're going to see around sort of 70 dBA of noise level. So you can't put this in an office. So these air caps you're going to see on the front of these units will give you a certain capacity, anything from 2.5 litres an hour up to 15 litres an hour. And obviously, if you can imagine 2.5 litres an hour of spray, try and equate that into 2.5 metres of distance of spray pattern off the nozzle. So if you've got a very tight area, you may need more nozzles with a smaller air cap to give you the smaller duties to get your capacities in. In terms of the operation, we're trying to regulate the flow of air pressure into these units with a panel, which is going to have a regulator for air and water coming in at 4 bar, and then reducing that down to 2.2 bar for the air, and obviously whatever the capacity of the nozzle is, obviously on the water side. Once we get that correct and the design of the pipework is correct, then we can spray uniformly across the room. And they're normally going to be controlled by a sensor to control that, or a number of sensors to give you an averaging of the room space. So these are typically room-mounted systems, but they can also be duct-mounted as well. But a good energy system, and obviously what to consider with a compressor and water system, you're going to find that the aerosol size of these are less than 10 microns. So therefore, then it's going to take less space to actually absorb into the airstream. So very, very useful for that to understand. But obviously controllability ±1, possibly in an induct system using RO water and a modulating sensor, but useful for applications where you're looking to get sprayed localized, and some of this can give you some localized adiabatic cooling as well. So with these, Again, you're going to be doing your 2 disinfections a year to 50 ppm. And what we're trying to do, we're trying to get 50 ppm right to the ends of the lines of these spray nozzles. We have end-of-line valves, which we will normally take a reading to make sure we're getting 50 ppm at the end of the line. So we know it's coming into contact with all the pipes on the water side to make sure that's being kept clean. And we'll hold that in there for an hour or so, depending on the size of the system, and then we'll drain that away to neutralize it to drain. Also, we'll have a UV change annually, as we've said before. Some of these systems may also have a silver filter, which you replace depending on the size of the system. It could be 6 months or it could be a year. And off the back of those, you'll have sediment filters to prevent those quartz sleeves from coating up the scale. We'll also have an air filter on the air pressure side that will need to be replaced every so often. So we'll inspect that as part of our general maintenance. Also, what you've got to understand also is the nozzle. The nozzle will have a little bit of dust build up. The actual cap itself is Niflor coated to prevent any heavy scale build up, but you will get a certain amount of dust on the outside of the cap. So you physically need to go around and clean those caps at least once or twice a year, because if you don't, then you're going to find your spray patterns are starting to change and you'll get uneven spray. So that needs to be checked. Also, we need to make sure the panel regulation is checked on a regular basis each year, because you're going to find the regulators will change in terms of the seat of the regulation, and you might find that you have to go in and adjust that every now and again. And there's also a valve kit or a regulator kit that needs to be replaced every so often as well. If you've got particular tight areas, what you can do, you can also adjust the individual nozzles. As you can see with our engineer Steve on the photograph there, he's actually tweaking that nozzle to actually give a finer spray just on that one nozzle. Ideally, if the system's set up correctly, you should have uniform spray across all the nozzles. So, high pressure spray, this is something that was brought into the field a few years ago now, but it's been around, and it's something that's is quite useful if you've got multiple areas that you want to humidify. And what it does, it basically sprays water, RO water, very fine, good quality RO water, up to 80 bar. And this sprays water out to, or pressurizes water out to a number of valve sets if it's on a ducted system, or a spray system that hangs down from the ceiling with a bed of air with a number of nozzles connected into a ring. And this will give you zonal control. So you can have up to 4 stages of control, 4 AHUs off one pump station. So these duties can be anything from, say, 100 litres up to 800 litres, or even bespoke system over 1,000 litres an hour. So they give you a bit of cooling. They're obviously fairly low in terms of operational side. And what you're going to find, most of the manufacturers either have a pump. The most important thing on these systems is a pump. So you're going to find either an oil-based pump or a water-cooled pump as an option. So these are going to be spraying out into the room. Now, with a high-pressure spray system, it's going to differ from the water system. Is that the droplet sizes are going to be slightly bigger. So what you're going to find is you might need more distance to spray with a high-pressure system, but also you're going to find with high-pressure systems there's less noise. So you can find you can use these in areas where maybe they're more occupied and there's not too much of an issue with noise. So that will help obviously with the application. So these can give you control down to plus or minus 1% in certain applications, because they can give you stages of control either in lines of valves, lines of nozzles, or numbers of spray systems in room. So from a maintenance perspective, what we need to understand is about sediment filters on the RO. Most importantly, the RO needs to give you quality water around sort of 5 to 10 microsiemens. So that RO needs to be maintained and checked twice yearly at least, and also checking that the membranes are giving you the quality of water off the system. With these pumps, if it's oil-based, it could be a 2,000 hour oil change you need to carry out. And also, if it's working particularly hard, you may even have to change the manifold, because the pistons and the packings in those manifolds will have to be replaced every so often. We're going to do a disinfection like we would do, obviously, for the evaporative systems and the cold water sprays on the compressed water. And we're going to make sure we're getting that ppm of fluorine all the way through the lines to the end parts of the system. With the nozzles being a ceramic insert, you're going to find with high pressure, they will have a certain amount of failure rate. So it's not uncommon to maybe say a 3 or 4% failure rate over a year. So nozzle inserts nozzles are definitely worth changing and checking and changing out if they're not spraying correctly. And that will apply also to the spray pattern itself as well. Also, hoses need to be checked and make sure they're all okay, and it's worth changing those periodically as well to prevent any issues with biofilm building up inside there. And if you've got an induct system, it's always worth cleaning down the blade eliminator, because with these blade eliminators, they will have a certain amount of water being run across them. So it's always worth spraying them down with a disinfectant to make sure that's clean and the areas are clean. So moving on now to a hybrid system. Now, some of you may have never seen this before, but this is a system, it's going to give you the best control with the lowest energy in the marketplace. Now, how we do it is a combination of the two systems you've already seen. Now, with this system, rather than using high pressure spray, you're using low pressure spray. So there's less energy consumption on the pump. So you're running around sort of 10 bar, and you have multiples of very small outputs of nozzle to give you the duties you need. So these can go with anything from 7 stages up to 31 stages of control. So you've got very minute changes of output. And then what you're going to have is then a spray, which is going to be switching these nozzles on, and you'll spray into the air, and anything that's not captured in that spray as part of the section will be evaporated off the meter itself or the ceramic plates you're going to see. So this can give you low energy and close control at the same time. So in terms of maintenance, it's going to be a disinfection. You will have to change the nozzles every so often to make sure they're spraying correctly. Also, you can have a silver system. The silver dosage system would have to be replaced every so often. That's normally on a counter on the display of the cabinet, and that will need to be replaced. But what you're going to need to be doing also is cleaning these ceramic plates down as well to make sure they're being kept clean, because obviously they can also act as a filter. So it's worth just making sure they're being kept clean. Wipe them down. If there's anything that's cracked, it's also worth just changing those out. But it's very similar to the way the high pressure system works in terms of the requirements for a hybrid system. So you 2 disinfections a year. So talking of disinfections, talking about hygiene management. Now, these humidifiers tend to sort of fall into the category of HSG 274 Part 3. So I'm assuming some of you guys have got cooling towers in your building. So these humidifiers should be added to your water management scheme to make sure that they're being tested on a regular basis. And normally what we recommend to people and to clients is that they should be doing a self-risk assessment of their water supplies or the application to understand how often they should be checking their water, checking the conditions of their water. So regular dip slides being put in place. Now, it's very, very important to make sure where you're taking these tests as well, because I've seen people taking tests back at their water storage tank, which is miles away from where the humidifiers are. So it's very important to make the tests in the inlet to the humidifier and also from the humidifier itself on a regular basis. Now, that can be either a weekly or a monthly thing, depending what comes back on your water risk assessment. But as a minimum requirement for disinfection, it's normally 2 disinfections a year. And then you would change your disinfection regime depending on what your dip slides are coming back. So it's always worth having that water regime in place as a backup to your system in terms of your standard 2 disinfections a year. So final stretch now, improving on a system. If you were to try and replace an electro boiler with a resistive humidifier, if you run it with RO, as I said before, you're going to take out all the solids and you're going to get better control, better response, less consumables than you would have obviously with an electro boiler. And the scale management side of things is a lot easier to cope with, a lot less worrying about the expensive 400-pound cylinders. So this is something you can look at, if you've got facility for RO, even better to work with an electro boiler to change to resistive. If you want to look at big duties using an electric steam unit at the moment, you go to gas. What you've got to consider is if you go to gas, the turn down rate on a gas burner isn't going to be anywhere near as good as what a resistive humidifier will give you in controllability. So if you've got a wired control band, say plus or minus 10%, slow air change rate, then a gas might be the way to go. You've got to save energy. But what you've got to consider is you're looking at the gas supply, ventilation and flue in addition to the unit. So, you know, if that's not in place, then it might not be an option to look at gas. If you're looking at trying to convert from steam to cold water, now the first thing you've got to consider is because of that adiabatic process, you're going to have to look at having a additional preheat in your air handling unit. In most cases, you probably won't find it's not available because it's going to be looking at the standard isothermal process, which is not going to give you any heat gain heat drop in the system. But if you've got additional preheat, then you can look at an adiabatic process. You can look at the cooling aspect as well as part of your process you control, so that's going to give you benefit there. Also, you're going to have to consider section length now with these units, because if you go for a spray system, if you look at high pressure spray, you're going to need a longer distance length to get that cold water system into place and get it to evaporate correctly. You've got to also consider the airflows, because obviously if you're trying to change to an evaporative system, there is a certain level of velocity the air will pass through that media. Now, if the air is too fast, then the evaporative system will not work effectively at all. But also, you've got to look at your water quality as well, because you can't spray, for example, without having RO water in an in-duct system. So all those things you consider if you're going to want to go to a cold water system. It's not exactly straightforward, not straight away, quick fix and change out. So now I'm just going to quickly touch on the common errors in troubleshooting. We see this quite often in commissioning over the years, in that with the steam absorption, we'll see a sensor maybe put in maybe a meter away from the lines. Now, what's going to happen, as you can still see water vapor coming off here. So if this is, say, a meter at this point, you're going to be coming off 95% here. And what's going to happen is it's going to either click the high limit and turn the humidifier off and go into the security open loop circuit, or it could be a modulating signal which will just ramp the humidifier back. But what's going to happen is you're not going to get the humidity in the space where you need it, because the sensor's still sensing at this high level here. So normally what we recommend that the absorption distance needs to be 5 times the absorption distance to mount your sensor to give you the correct controllability. Also, we're going to see sometimes that people are opening up fresh air dampers. Now, we're going to select on fresh air supply, how much fresh air is going into the system. If someone now is looking at opening up fresh air, especially now with the new stage requirements, that you're going to see that more fresh air is being required now in these areas, that's going to have an effect on the humidifier. They make the humidifier undersized. Also, you're going to see with small rooms, if people haven't accounted for a DX evaporation, so you might have a split system in your room that's working on a certain amount of sensible cooling and latent cooling. Now, if that coil on that system is running all year round, that's going to be stripping out moisture all year round, and therefore you've got to allow for that in your application and design. Also, we see an awful lot where pipe runs are too long. Maximum efficiency for steam systems is 4 meters. If you go above that, then you're starting to lose more steam through condensate. Also, if you've got lots of bends, that's going to affect the output of the unit, and also restrictions like kinks will affect the outcome of the unit as well. Another thing to also consider is the positioning of the unit in terms of its drain. So if you're positioning the unit above a drain, you are going to get corrosion because you're going to get flashing steam off the drain. Also, it's very important to understand where you're putting these units outside to make sure you have the correct type of enclosure and also the correct heating, ventilation and thermostats to control the level of the temperature within the enclosure above 5 degrees. If it goes below 5 degrees, then you're going to see sweating on the boards, which can damage the boards. So we touched on this a little bit in terms of inlet pressure for isothermal steam humidifiers, but pressure is very important onto those humidifier valves to make sure we're getting the correct flow rate. Hard water, as we talked about with the scaling, looking at cylinders, making sure they're the correct type. The one that I see commonly all the time is people trying to exchange the raw mains water for softened water. Now, softened water, basic exchange softened water is you taking all your calcium out for a resin filter in your softener and exchanging that with sodium. And as I said earlier on, when you put your sodium into a saucepan at home, it boils it very, very quickly, and you're going to find that it'll foam. And what you'll see then is foaming action and a damage in the electrodes. So softened water is, I would say, is a no-no, obviously, for using with electrode boilers. You're better off sticking with raw mains water. Also, as I said about Scotland, you've got options for cylinders. Some of the manufacturers will give you cylinders that go down to less than 100 microsiemens. So if you've got issues with your water on in sites in Scotland, there may be a different cylinder out there that might help you get control. Control sensors, as we said, about being in the wrong position. Another factor I see an awful lot of is that the humidifier probably runs through the winter period and it then turns off for the summer. Ideally, really what you want to do is drain those cylinders down at the end of the season before they start the season again in September, because if you leave them in water, those electrodes are going to rust, and then you get the mild stir exposed, and then all of a sudden, oh, look here, we've got a problem now with the unit not working at the start of the season. Drain pump and valve issues, as I mentioned, is very important to make sure they're draining and diluting correctly. Burner lockouts, we see sometimes if the units are on a roof somewhere that they're actually using inconsistent gas pressures. That's going to have an effect on the burners, and also making sure the electrodes that spark the system are actually changed on a regular basis. To look at also common errors with adiabatic systems, if you're looking at an adiabatic adaptive system, we commonly see sometimes with commissioning that when we get a design, it's 10% higher actually when they get to the commissioning stage because of the air balancing side of things. Now, if that's actually selected right on the cusp of the maximum of the velocity, you're going to find that you might have carryover issues. And also, this is very prevalent now, obviously, with the stage requirements to actually up the fresh air rates. So if you're up in the fresh air rates, it may be a case that you might be increasing your air volumes as well, possibly, and that will have an effect on the unit. Also, I've seen in the past where the media of an evacuator unit is almost acting like a secondary filter because the filtration in front of it is not adequate, and therefore we're getting dirt and muck that sits on the back edge of the media, and then you're going to see media life reduced dramatically because it's got issues with hygiene. You can't physically get in there to clean out. Non-laminar airflow is another one we see where you're going to find if you've got the incorrect airflow, you're going to get incorrect saturation efficiency on the media because the air isn't straight all the way through the media itself. So non-laminar airflow is another one. As we said about insufficient preheat, and also section length, as I said about with the spray systems. So RO water quality is another one, especially with sprays. It's vital that you keep that working correctly. If you don't, you're going to find then you're going to see more nozzle replacements and inconsistent sprays. And also you're going to see issues with pressures with the water and air pressures with a compressor and water system. You've got to make sure that's being regulated on an annual basis to make sure you get the correct spray patterns. Right, I think I've just overrun by about 3 minutes, but I think I'm there now. So thank you for your time. I hope that's been of use. It's been a lot of information in a very short period of time, but I hope it's been of use to you guys. And then, Dave, if you want to start looking at any questions now, we can start from those. Thanks a lot. Thank you.
Well, firstly, thank you, Darren, for an excellent presentation. There was so much information to take on, and we do have some fabulous questions. So I'm going to dive straight in and put some of these questions to you, Darren.
Okay.
The first one is, would you recommend any form of sampling, i.e. legionella sampling, from an adiabatic or spray humidifier?
Yeah, I mean, if you look at the HSE requirements, it's normally a requirement to actually sample those legionellas at least twice a year. So, you know, take a sample, get that sent away to a lab and get that checked out. So if you read some of our manuals, there is a requirement to indicate that you should be doing a legionella test every 6 months to make sure that's being checked on a regular basis over and above your dip slides.
Okay, brilliant. I have another question here, and it says, there's any mention of water quality that should or should not be provided to a humidifier?
How do you mean by that?
Is there any water quality that shouldn't be provided to a humidifier?
Yeah, I mean, obviously, you're going to have water quality ranges which humidifiers are going to work to. So invariably, they're going to be up to anything from sort of 50 to 60 microsiemens up to 1,000 microsiemens. But if there's any doubt and you're concerned about any water quality with a unit, I think it's always worth giving us a call. And if you can't find that information, what I tend to use a lot is actually looking at the water authority. So you can go on to Find My Water Supply and put in your postal code, and then you can find the quality of the water. Now, we'll look at conductivities from an electric humidifier perspective. So anything above 500 microsiemens is going to be pretty much high water. So we can give you guidance, obviously, how many times a year you would clean the unit. Now, if it's 500 microsiemens, I would be looking at maybe 3 to 4 maintenances a year to keep that system working correctly, as in a planned preventative maintenance. If you leave it less than that, you're gonna be opening yourself up for maybe a cylinder replacement in between those services, and you'll have an inconsistent operation of the system.
Okay, great. We do have a question. It's a very common question. Is there a difference between RO water and softened water?
Yep. Yeah, obviously with reverse osmosis water, what you're doing is you're taking 90% of the solids out of the water through a semi-permeable membrane, and then releasing that into the humidifier. Whereas with softened water, all you're doing, you're exchanging the sodium with the calcium. And what you're going to find with the sodium system, the softened system, is that you'll still have iron and magnesiums being boiled out into inside the cylinder. But what you're going to find with the softened system is that there'll still be a lot of scale in there, but be more of a finer powdery solution, which is not particularly great sometimes some of our units, because it's very hard to get out. And also you've got this aspect of foaming, which we talked about earlier on, that can be an issue. So if you're going to look at the way to treat the water, I would always tend to look at RO water, unless it's an electro boiler, because you need that in the water to actually get it to boil. But others, RO will be the best way to go.
Fantastic. We do have another question. Do electrodes or gas-fired humidifiers require disinfection twice a year?
No, we would say not. I mean, because obviously, provided you've got all the pipe runs and the drainage off those pipe runs correct, because you're boiling the water at 100 degrees C, the chances of any legionella issues are going to be very, very minimal, hardly at all. So we would not recommend obviously doing a disinfection, because anything at that temperature is being killed off. Provided that the drains on the system is all running correctly and the condensate drains are correct and they're running away correctly, then we'd only see it on a cold water system, because of the temperatures are a lot lower, and therefore then you've got more of a possibility for that legionella to survive or bacteria to survive. So it tends to be we don't disinfect on a steam system.
Okay, thank you, Darren. We do have another interesting question. It's from Marcus. It says, who asks, we have a client who don't like proprietary or black box controls on their projects and want the building's BMS to do as much of the control as possible. To what extent is this possible with the units we're discussing?
Well, most modern systems now will come with Modbus and BACnet with their system. So over the years, we've had 0 to 10 volt signals, analog signals going in and driving the humidifier up and down. But with you've got also interlocking for the fan and high limit. But with the BACnet options now almost coming out standard, you've got facility to read a lot more information. So rather than just getting a common alarm, you've got loads of information coming back to the unit. And obviously at the moment we're talking about integrating these into IP addresses to actually see them remotely, look at remote access. So BACnet and Modbus is something that we're looking to expand on in the years. But if you look at most manufacturers, they'll either give you BACnet or Longworks as an option to look into. And invariably it's just going to be then a signal, you drive up and down, and then you can monitor the information coming back from the humidifier.
Okay, I do have another great question here. Is it more efficient to preheat air than it is to use a resistive type based on the rate of energy absorption?
It probably, yeah. I mean, if you're preheating the air with a gas indirect heater, if you're looking at an adiabatic system, that's probably going to be cheaper to boil the water electrically than you would do with a resistance heater. But what you've got to consider with this is, if it's a process area, you probably wouldn't get the same level of control with an adiabatic system, or if it's an abatic system, it will be a plus or minus 10 scenario, whereas a resistive electric system will give you plus or minus 1 and respond to high air change rates. So you will get less energy cost obviously with using the adiabatic system, but you need to weigh that up against actually the controllability you need in the actual process itself.
It does raise a really interesting point, because it's really important that people understand that actually whether we're adiabatically humidifying or if we're isothermally humidifying, the energy required to change the state of the liquid is the same. So if we're doing an adiabatic process, I've got to preheat the air to give the water the energy required to change its state in the form of preheating, as opposed to a steam generator where we're just using electrical energy straight into the humidifier. to produce steam. So the enthalpy difference is exactly the same. So the difference is the cost of the energy that you're using. Is it cheaper to preheat the air using the heating that you've got available to you, or is it cheaper just to use maize electricity? And that's something that's site specific, or indeed you may have a cheaper source of heat energy available to you, which you'll be able to offset against the cost of preheating. Thank you, Darren. The only other question I have that we can address that we have time for today is, how many times can you clean an electrode boiler cylinder before you would consider replacing it?
Good question, because if you look for places in Scotland, you tend to find the polypropylene will actually not last as long as the electrodes. So most plastic polypropylene will last for about 4,000 or 5,000 hours, depending on the manufacturer. So you're going to find that if you get, you invariably have a counter on your humidifier to tell you how many hours you've done. But in most cases, you're going to find you're going to get, say, maybe 3,000 or 4,000 hours on the electrodes, and they'll all be coated up with scale by that point. But I would say a ceiling level is about 4,000 to 5,000 hours with the plastics, because what you'll find is the plastics will eventually degrade, and you'll start to see stress cracks on the polypropylene. So I would say if you're working in Scotland, for example, I would definitely change the cylinder after a year of operation. Now, that's 4,000 or 5,000 hours. You know, it's going to be more hours in a year, but that's assuming it's going to be working purely through the winter season, not all year round.
Well, that's fantastic. Thank you very much, Darren, and thank everybody to everybody for joining us today. It's a real pleasure to be able to deliver these webinars to you. There are some questions that we didn't get around to asking Darren, but we will get back to you directly from an email. And of course, the handouts will be available, and you will get an email with a link so you can watch a recording of the webinar. So with that, again, thank you, Darren, and thank you to everybody who joined us today. It was great to see you all. Thanks very much.
Thanks, guys. Thanks for attending. I hope you learned something out of this, so I can take something away. Thanks a lot.